Okay, so we're looking at inverse variation today. It's the second part of our chapter 2. And this is like direct variation, except it's kind of flipped on its head. Okay, so I'll show you in a minute. So the first thing is you need to know the definition of inverse variation function. An inverse variation function is a function that can be described by a formula in the form y equals k over x to the n. Okay, that's how it's different. Remember, with direct variation, we have, just to remind you, put it on the side, it's y equals k times x to the n. Do you guys see the difference between them? Okay, so the k is on the numerator, x to the n is on the denominator in this case. So for the inverse variation function with equation y equals k over x squared, we say that y varies inversely as x to the nth. In this case, it was to the second because they gave us 2 there. Okay? Or y is inversely proportional to x to the nth. In an inverse variation, as either quantity increases, the other one decreases. Good. All right. So, example 1a. What we're going to do is we're looking at a speed of a bike, and it varies inversely with the number b of back gear teeth on the rear wheel. Write an equation that expresses this relationship. So we're looking at inversely proportional, so we have S equals K over B. K is the constant, B is the variable. One B is similar to that. Let's see if you guys can take a second and set it up without watching me do it. Take a second to do that, okay? Hopefully you got U equals K over L. Yes?
Isn't it U equals K over L squared for the
In this case, it didn't tell you it was to an nth power. If it said to the square of L, then you would put L squared. So they will, just like in the last section, they generally told you if it was to a power of something, okay? So solving an inverse variation problems. According to the law of the lever, or lever, depends on what part of the country you're from. In order to balance a seesaw, another person must sit a certain distance from the pivot, or the fulcrum of the seesaw. This distance is inversely proportional to his or her weight. Algebraically, D equals K over W. And since D is inversely proportional to W, as D increases, W will decrease. This means a lighter person can balance a seesaw by sitting farther from the pivot, farther from the center. Or a heavier person can balance the seesaw by sitting closer to the pivot. How many of you guys have been on a seesaw before? Okay, because they're dangerous now. They're not even on playgrounds anymore, which is a bummer because I think they're a great learning tool. I just remember when I was a child and sitting with my dad, and of course he was way heavier than me, and I figured that out. I'd tell him to move closer, and then I could sit on the very end and keep him up in the air. I thought I was so cool. So anyway, so there you are. So we have Ashley and Sam and they are trying to balance on a seesaw. Suppose Sam, who weighed 42 kilograms, is sitting 2 meters from the pivot. Ashley weighs 32 kilograms. How far away from the pivot must she sit to balance Sam? So, first of all, we already know that D equals K over W. And the first part, we know that the weight was 42 and the distance is 2. So that'll be 2 equals K over 42. So if I want to find my constant of variation here, if I multiply both sides by 42, I get 84. So the second part says, how far away must from the pivot must she sit to balance Sam if Sam weighs 32? So D equals 84 divided by 32. So she must sit 2.625 meters away from the center. Okay. Okay, 2B is the same thing. I want to stop the video and stop for a moment and let you guys try to do this one on your own. Okay? So go do it. Okay, so let's check your work. You should have gotten 1.8 equals K over 34 for the first part. And if you multiply both sides by 34 times 1.8, you're going to get 61.2 for your K. Then if you put D equals 61.2 over W for your new equation, you should have 38 for your weight. So that's going to be D equals 61.2 over 38. And then that should be like 1.6 meters. So hopefully that's what you got. Okay, an inverse square situation. Just as one variable can vary directly as the square of another, one variable can also vary inversely as the square of another. The next examples illustrate this, where the intensity I of light is inversely proportional to the square of the distance from the light source. So here is our formula right there. Okay, so you can see D is squared on the bottom. So 3A says, suppose the intensity of the light 4 meters from the light source is 40 lumens. Okay, so what is my I value in this case? 40 equals K over, and then the distance is 4, so that'll be on the bottom, and that's going to be squared. All right? So now, I need to solve for K. That means I'm going to multiply both sides by 4 squared, which happens to be 16. So 40 times 16 equals K. That ends up being 640. So we now have K. That will be I equals 640 over D squared. Now the next part says, find the constant variation and then determine the intensity of the same light that's 6 meters from its source. So that'll be 640 divided by 6 squared, and that should have given you 17.8 lumens. Okay, 3B is the same thing. I'm going to pause the video again, give you guys a chance to try it and see if you got it right, okay? So on this one, we have 30 lumens and 6 distance, okay? So we have 30 equals K over 6 squared. So 30 times 6 squared is 30 times 36, which happens to be 1080 for K. Now, if I want to find out how many lumens it is for 9 meters away, that's going to be I equals 1080 over 9 squared. And you should have gotten 13.3. So your homework for tonight, page 83, numbers 1 through 10 and 12 through 22.